So Jim, tell me something that you would never tell anybody else because we're completely alone in this webinar.
Oh, really? You want to hear a secret?
Yeah, tell me one of your dirty little secrets. Come on.
Owen, I feel guilty, but sometimes in some of my software, Owen, I don't always update my JavaScript third-party libraries. And it's something that really is, I feel guilty about it. I feel guilty because if I can update the server-side libraries, Owen, I can make that work. But trying to keep up with like Angular updates, it's like I can do nothing but update 4 hours a day, and I don't always update my JavaScript framework. Owen, forgive me.
That's okay. I think there's the 12-step process to getting over that hump in your life. And
I admit I have a problem. I'm not into updating client-side libraries. My name is Jim.
Yeah.
I'm a non-updateaholic. I'm sorry. Hello, Jim.
Hi, Jim.
Hi, Jim.
Yeah.
Good afternoon, everyone, or good morning, or good evening, depending where you are. Welcome to the 2022 Vulnerability Statistics Report preview webinar. And today we're joined by Eoin Keary, CEO of Edgegun, and Jim Manico, founder of Manicode. And so I'll let Owen and Jim kick it off.
Thanks. Hey, hello. So yeah, what are we doing here today? I've asked Jim to jump on. Myself and Jim have a sordid history for many years. Jim is one of the best technical security coding trainers I've ever met. Probably in effect, one of the best on the planet currently. And I think I'd love to hear his view because finding vulnerabilities, keeping hackers at bay, keeping the wolf from the door is all good and well, but one of the things we need to talk about is how can we find less vulnerabilities? How can we put companies like Edgescan out of a job, such that people are coding so securely that there's not much left to find? So it's really that type of thing. Some of the statistics are pretty interesting, so we can launch into them, and the idea will be just to have a conversation with Jim. I think you guys can raise questions and stuff via the webinar. I'm not sure if you can or not, but hopefully if you do, you can get them to us somehow, either on Twitter or something like that. I don't mind. A little bit about Edgegun, and then Jim can jump in. So yeah, Edgegun, we're a vulnerability management SaaS. We're full stack, which means we cover off the network and device layer, API, web application layer. We also include things like attack surface management and pen testing as a service. We deliver this Edgegun service. We deliver it to we've over 200 global clients. We have hundreds of thousands of assets under management, and we do it in a continuous way. And we've been doing it like that for the last 5 years. So it's a lot of the statistics here are based, well, all of the statistics here, apart from maybe some of the opinions, are based on what we're seeing, and the statistics we're going to talk about today are based on the data up until the end of December 2021, so the 12 months prior, so the entire of 2021 in effect. And it pretty much talks about full stack security. The reason we talk about full stack in effect is because AppSec and network and all this different flavors of vulnerability management and pen testing, to be honest, if you look at ransomware, threat actors, cyber criminals, hackers in general, people don't want to break into your systems for fun or for profit. A lot of them don't really care where the vulnerability is, and that's why we sort of do full stack. Jim, do you want to go for it?
Owen, hello. Owen, what interests me is that you and I were talking about application security statistics about 20 years ago at OWASP Portugal and similar, and so here we are 20 years later, and we're still debating and discussing application security. It's still fun, so it's real interesting to talk to you after all these years and to see what's changed and see what the trends are. As you know, Owen, I deliver secure coding training. I've done it for about 15 years now. I study application security, build PowerPoints, and give presentations on how specifically to write secure code. It's something it's a lot of joy for me to do. I enjoy it. I have a bunch of professors who work for me, and I love Edgescan. My favorite Edgescanism is that you're covering the full stack, right? You're doing web, API, and you're doing network and infrastructure. There's not a lot of services that do that. So that full stack capacity is something that makes me and my customers very happy. So, hey, power to Edgescan. I know you've been working on it for years. It's great to be
good.
thrilled.
Great, thanks, Jim. So let's on with the show. Let's move on there. Slide person. Let's move. Yeah, okay, right. So first thing we're talking about, and this is sort of the thing we've done every year in the stats report, is risk density, which is a fancy name, in effect, to say what percentage of vulnerabilities are of a particular risk as a percentage of all vulnerabilities discovered. And we do it in three ways. And Jim, I'd like to maybe understand what your views are. For example, when we look at full stack, if we add up the critical and high percentages, we're looking at about 20-odd% ish. But then when we move it to application and API layer, we're looking at about maybe 9%. And then if we split out the network and device and host sort of there, we're looking at about 17. So is this sort of a trend that you would expect, or for me personally, it's because there's a few things. One of the things is the last year there's been a ton of patching and CVE things. Ransomware was huge. Lots of stuff like that. And then again as well, we talk about the age of CVEs, the stuff that we'll cover off in a little while. But the staple vulnerabilities of web application are still there, right? So SQL injection, cross-site scripting, and all remote command execution, and all that type of thing. Well, what was your feeling when you first saw this sort of model, this statistic?
So when I look at reports in my world, I usually see the web application distribution where you're seeing like 9% or so of vulnerabilities that are higher critical. I think of high and critical as really immediately actionable. I really got to do something about that. And that's a percentage that I typically see. But when I see the full stack, those are not statistics I usually see on vulnerability reports. That's 20% of immediately actionable vulnerabilities. So my question is it because you're just able to find more things at the network layer, or is it because you have a high fidelity engine at Edgescan for network type work, or just in general your assessment? But it's surprising for me to see so many high level network vulnerabilities. That's a spike over other things I've seen. Why do you think you're finding so many actionable network layer problems?
Yeah, that's a good question. I think when we move into sort of how quick people are fixing stuff, I think people are not fixing stuff on the network layer that much. I think there has been a great movement, and we can talk about it in terms of DevOps and trying to speed up fixing of code. But the traditional let's patch stuff. Is still it's archaic. I know cloud has removed this idea of patching to a greater extent, and the more we move to cloud, maybe the quicker these things will be resolved. But they'll still exist, but maybe we can get rid of them quicker, because we can just tear down an instance and spin up an updated instance without that vulnerability. But there's a mix. Like in terms of Edgescan, it's very much around we do put a lot of work into network scanning, into how we find vulnerabilities, and the thing is with this, which is probably worth mentioning, is all of these statistics are based on verified vulnerabilities. It's not like we're not finding vulnerabilities and then just pushing them out and saying they're real. Everything we publish to our clients is a verified issue. It's not so we try to avoid false positives, I think is the word.
You do human verification to verify your vulnerabilities?
Yeah, we do a little bit of that. So it depends on the issues. Gotcha. Some of the issues can be verified with technology.
Awesome.
But then if you get into business logic or some complex issues, I think the Log4j stuff that we had in December was a real hybrid effort. Gotcha. There was tons of false positives. We built our own scanning for that within maybe a few days of Log4j breaking on the internet, and everybody was rushing around trying to fix it. And it's a weird issue because it's about a reflective sort of idea that it's a code execution that reflects, and you can reflect into, say, some other domain, and to be able to capture that and see if that's happening behind the firewall of an organization. It's full of false positives, but it's a big mix. I think the ultimate idea for us is hacker. Pardon my France, but hackers don't give a shit, and we think the full stack view is the most accurate view of internet security, as opposed to siloing web and network. But then again, not developers are interested in the web and API side of security, and then people that manage networks possibly will be more interested in sort of the more CVE patching side of the world. So full stack is a combination of those two things.
But this is interesting because it's like I would expect to see the opposite here. I expect to see web with a much higher vulnerability density because it's so difficult getting programmers involved and similar to fix those bugs. And network level devices, I mean, we have a lot of good scanning technology, and in your patching, you're not like getting engineering involved to like write new code. You're applying patches. So I'd expect to see the opposite. So what this tells me is that companies are getting more mature at fixing web layer vulnerabilities, or at least building secure software, and that managing network devices is managing networks is not nearly as trivial as people think it is, and patching is not easy. And the percentage of problems you're seeing at the unpatched network is way eclipses web by a wide margin, and that's
it's weird, isn't it? The world's gone back on itself. Like, the idea of attack surface management, ASM, what is that really? It's profiling internet facing systems. It's something we've been doing since Nmap. We've been doing it for 25 years or whatever ever old Nmap is. But now it's a technology or maybe an approach of note. People are saying we can't secure what we can't see. I think a lot of the traction in the cyber industry is on the API layer specifically. It's also it's always been strong on the web app layer. There's so many ways of peeling that orange, But the thing is that maybe the idea of new and cool technologies to assist in the speed of fixing network vulnerabilities just isn't there, because the market is screaming for it, like the way it's screaming for API security, or it's screaming for ASM or something. So yeah, that's a really good point, Jim.
And the trend is that I'm going to have to manage networks less and less over the next couple of years, right? It's like it's all going cloud, and believe me, cloud has its own problems. But one last thing I like about this is these statistics are all exploitable. This is so. I think of Edgescan and the whole industry of like managed vulnerability assessment as a service, and with that verification step, when you're feeding data to me and my customers, it's like. This is not like theoretical. This is what's exploitable. So it's like
that's a really good point.
Data. Yeah,
it's a really good point, because when we talk about there's a blunt instrument we have in the industry, CVSS scoring. Like PCI standard uses it. It goes from 1 to 10. And if a tool, a dumb tool finds something, it says, right, this is the vulnerability, and here's a number. It's between 1 and 10. 7 to 10 is higher risk, and then 1 to 6 is sort of medium and low risk. But a lot of that doesn't have any context. And when you talk about secure coding, when you talk about sort of securing anything and risk, it's all about context. And when we risk rate something in Edgescan, particularly when it's as it's being validated, if it's exploitable, it's going to get pushed up, in terms of risk score. So sometimes you'll see in Edgescan as the CVSS score, the vanilla CVSS score could be. It can work both ways. It could be like a 5.0, where when it's validated and we see how exploitable it is, it could be a 7. It could really be a high risk issue, even though the CVSS score is lower. And on the converse of that, sometimes the CVSS score is a 9.0, but then when the issue is validated, it's actually not that exploitable because there's other controls there. There's other conditions that need to be met. So So real risk is important. Real risk and accuracy helps prioritization. Without those two things, it's really tough to keep all the whack-a-mole heads, to keep the landscape clean, to try and be resilient in some way. Without those particular two data points, it's quite difficult.
I think the vulnerability scanning industry in general, I think like moving from like mass vulnerability scanning to like more exploitability kind of engines, that's the trend now. I see that in a lot of the new network security tools and other tools in the space. Companies are not interested in wading through false positives anymore. They stopped being interested in that a long time ago. So there's a whole generation of new tools coming out that focus on exploitability. And I know Edgescan's been doing that for about 5 years now. So I think that's a really interesting trend in our industry as well.
No, I agree. When we were young, Jim.
When we were young.
When we were young.
Alexa, play Adele when we were young.
There we go.
Sorry, Alexa, quiet, please. Sorry.
But
I'm an Adele fan, and I'm not ashamed of it. Owen, go ahead.
Oh, it's okay. It's all right. I prefer the Irish folk music we were playing before the webinar. But Adele. Like when we were young, tools, the fatter the report, the better the tool was, right? The more stuff in the report, but it's very much around, the way I see it now, it's about noise suppression. It's about, look, I ain't going to fix all the vulnerabilities. No. I can't fix all the vulnerabilities. We can talk about MTTR and stuff in a few minutes around how quickly we're doing it and depending on the size of the organization, but I haven't got the resources to fix all the vulnerabilities. I can't be 100% secure, but what I can do is maybe fix the ones that really matter to my business, the ones that really could impact my business or my data, or give me a headache on a Friday or Saturday night, because it always happens on a Friday or Saturday night, when things go wrong. So noise suppression and the idea that less is more, I think, is really important now. It's about trying to get rid of the white noise and get some of the fidelity, as opposed to getting these big fat reports. And I think that's something we try to do, in Edgegun. I think a lot of organizations, in the industry today are going in that direction as well.
I'm with you.
We go to the next slide there, Theo.
Let's do it. Yeah, it's one slide. One slide.
Yeah, I know. Oh, this is going to be a long one. I know.
It's good.
But meantime, this is it.
Owen, this slide just makes me want to look away. This is horrible.
I know.
Sad. This is depressing. This is not even close to statistics that I want to see when it comes to remediation, because finding bugs, that's important, but that's not security. This is security, and we're not doing a good job of this. This is upsetting.
No, I totally agree. Finding vulnerabilities and verifying them and telling people they have issues it's the easy part in some ways. The hard part is, what do you do? How do you
put 5 years of your life into maturing assessment capability? It's not that easy. I got to give yourself a little more credit.
All right, thanks, man. But it's now I have a big bucket of shit here I have to deal with. How can I do this in a meaningful time? And the challenge is, how quickly can I remediate? And remediation is the way Edgegun looks at it, is from the day we find the issue to the day that it's retested and verified as closed, right? And I think, Jim, you could agree that fixing lines of code, most developers would say that's probably the easy part of remediation. It's all the other stuff surrounding it. Like we had a discussion before this webinar about pure DevOps and stuff. Do you want to share that again? I thought it was really
absolutely. Like, I've looked at, like, a lot of my customers have major vulnerability programs, right? Usually they already have vulnerability assessment by the time they're ready to train their developers, right? They're already into AppSec a little bit. So I've gotten wind of statistics of some of the companies that have mature DevOps capability, DevOps, right? When I say mature DevOps capability, I'm really talking about my DevOps pipeline is so dialed in that my developers can push code and it goes live right away. That part of DevOps, and that's the agility part. It takes years to get to that capability is what I'm seeing. But those who invested in DevOps for many years, their remediation rates are much better because they have the technology that allows them to push 100 times a day. And I got to tell you, most DevOps shops I see don't have that capacity. They have automated scanning and other parts of the DevOps world, but that live push, that takes a lot of stones to go live automatically from developer code. But those that do that and have matured that capability, like the Etsy's of the world, the real DevOps players, their remediation rates are radically different because of their capacity to push fast. So DevOps is not the answer to everything, Owen, but it does give me the capacity to remediate faster than any other kind of SDLC out there. So I'm a big DevOps fan, even though it's an overused term, and we've been doing it for 20 years. I still think the DevOps movement of automated security and automated pushing live helps these statistics great. But as an average, these statistics, last note, as an average, these statistics are horrible, Owen.
Yeah, they are.
It's not reflecting of your company. It's just fixing stuff is hard.
No. It's interesting. Like the quickest turnaround we had, if you look at the statistics in a deeper way, because this is just a preview, but the actual document, the quickest turnaround we had was about 2 hours. So there are organizations that within 2 hours are being alerted via an alert that they have a critical issue. Within a couple of hours, the issue's been closed off and shut down. And there is some companies do it, but the majority of companies aren't in that space. And I don't think it's that developers aren't writing code fast enough. I think it's just that it's the whole deployment. It's pushing to deployment. It's regression testing. It could be, sometimes when you apply patches, they break stuff. Sometimes when you update an open source project or a log system or some sort of piece of middleware, it breaks things that are hooked into it already. So if it's a live system, sometimes the call is, do we live with this vulnerability? Try and virtually patch it, try and firewall it off, or at least monitor that attack vector, because we know that the risk of fixing it immediately and pushing it live could break the entire system and lose us, a lot of money, if they were an e-commerce site or something. So it's never, when you talk about time to remediate, it's not how quick can you patch, because patching only takes a few minutes on any system, and fixing a few lines of code, it takes only a few minutes. So there are more complex design vulnerabilities you find, and you'll probably agree, Jim. Authorization issues can be complex to fix. Some logical issues could take some time to figure out what's going wrong, and and how do I fix it, because maybe the logic was missed, wasn't designed properly in the first place, or a use case was missed, and that's why there's a vulnerability. So in some cases, and to be honest, in my history, of being a pen tester in my youth and stuff, and simulating stealing millions of dollars from banks, I always found logical vulnerabilities, business logic vulnerabilities, are the vulnerabilities where they're the most effective. It could be an authorization issue. It could be, as opposed to, an injection issue. Sometimes injection issues are cool. We love doing them. Database dumps, but.
Injection is easy to find, easy to fix, right? The SQL, LDAP, all the injection class problems are real standard for the most part. And I think automated technology does a really good job at discovering SQL injection these days. We have a lot of years trying to do that. But now take a look at business logic, even something simple as an e-commerce workflow where I can skip a payment step. No scanning engine I've ever seen can handle that. Or even access control. Look, Owen, access control, we've known about that since like the late 60s with the first multi-threaded operating systems. In the 70s, we got Dr. Salter and Schroeder at MIT talking about access control design. Why the heck is it #1 in 2022? The OWASP top 10. And it's because automated scanners are not that good at finding access control problems, because everybody's application has a different access control policy. So Owen, a lot of the competitors out there, a lot of folks who do vulnerability assessment, they're very weak at discovering access control problems because it's a domain that automation is not friendly to. So I want to ask you, how do you at Edgescan handle authorization class of problems? That's automation is challenged there.
We have some automation, but it's not a silver bullet. The majority of our discovery is when we do pen testing as a service. So this is the idea that through the the product through Edgescan. In fact, you can get pen tested as well, and it's a combination of tech and all the stuff we built over the years, but it's also you know, think of it this way: there's layers of you know, there's technical vulnerabilities, and then there's logical vulnerabilities. So our automation would take care of the technical stuff, SQL injections, all that crap, and then in effect the logical stuff, the meaty stuff like that is done with one of our penetration testers. Because I don't think, I totally agree, we're not in a place where we have you know, applications, scanning systems that can understand the context in which an application runs, and therefore understands how to bypass and break the logic of that application. We're so far off that, you know, even with AI-based solutions, I'm not. It could be. I'm sure it's coming eventually, but right now, human curiosity and deviousness, you can't beat that. It beats any scanner any time. So you know, we've been very realistic about this, and what we say is we can find a lot of the technical vulnerabilities easy enough with technology, and then there are a taxonomy of particular vulnerabilities that still require human curiosity, or you know, an expert to pen test something or other. So yeah,
and this is why authorization is #1 in a lot of the different top 10 lists. It's hard to find, takes a lot of resources to find. You got to understand the app's policy, but for developers, it's often hard to fix. If it's a quick role change, it's easy, but it's rarely that these days. It's things like I'm able to traverse an ID on a URL and steal other data, and fixing that can be super complicated. So authorization problems are not going away. And, you know, I think I used to put authentication and authorization kind of in the same category of complexity, but authentication, my stats are showing it's less and less of a problem, because we have standard identity providers in our frameworks. There is no standard access control framework out there that's used at scale. And so that's why authentication problems are on the decrease of discovery and severity, and authorization is on the rise from some stats I've seen.
Totally agree. Yeah, I think the authentication can be standardized, because what you're doing, you're authenticating. There's no, you know, but authorization is very contextual, depending on what the application is. So yeah, it's an elephant in the DevOps room, I think, as well. You know, in terms of the doing things fast, you know, move fast and break things. You know, that used to be a thing, right? That Facebook used to say, but where are they now, right? But the thing is that I think automation really isn't gonna, you know, it isn't the silver bullet what we think it is. Let's move on to the next topic in the interest of time. Yeah, so this is an interesting one, Jim. It's around, you know, the average time to fix stuff, but it's based on the company size, right? So from 11 to 100 staff, it's 68 days, and then but if you go to, you know, 10,000 plus staff, you're still only, you know, it's 84 days average MTTR, right? So some people would assume, without looking at these metrics, bigger companies, more money, more tech, do things quicker. Smaller companies, no cyber guy, not sure what they're doing, do things slower, maybe not do things at all. What we're seeing is, in effect, that they're all around the same ballpark, within 10, you know, within 20%, right? Well, why do you think that is?
I think it's a fascinating statistic. Well, I can understand why it's so hard to fix for very large companies. I think the bigger your company is, probably the less you're doing thorough developer training. The bigger your company is, the more you need entry-level developers, or like developers at the earlier part of your career. When you go into more tech companies, that's a little less the case, right? I mean, entry-level developers can actually be harmful to your company. It's a hard problem. You got to start somewhere, but you know, so why is this? I can understand why a big company, because it's so hard to corral that level of developers, training, getting the right architecture in place. You often have like hundreds of different frameworks. That's a hard problem. I can understand why it's, go ahead, Owen. I'm sorry.
No, Jim. You know, in your experience, because I know, you know, Manicode. You know, your clients are like some of the tech giants. You know, everything from tech giants down to sort of medium-sized organizations. You know, and you're looking at hundreds or thousands of developers in terms of you know, people you've trained over the years, and you know, and teams you've trained. Would you do you see that it is very much an induction piece to make sure that all developers get secure code training, or is it more patchy? Where are we with that in terms of trying to make sure people are coding securely? Is it mandatory, or is it sort of more ad hoc and budget based?
I don't want to be so arrogant to say that secure code training is the solution, right? It's one piece. It's one piece of an AppSec program. I'll say this for a big company. I think the best way to handle security training in a big company is to identify like 1 or 2 security champions from each of your teams and have them go through really rigorous secure code training. And then their job is to be a knowledge liaison between like the AppSec groups and the actual developers. I've seen that where you have like not one, but a couple champions for security whose job is to transfer this knowledge to the other teams. I've seen that work for a really big company. I don't like a lot of the automated training platforms, not many of them at all. It's like, I do like classroom training or like in-person training. Sure. Just so developers can ask contextual questions. That's something that's important. But no good answer here. I think even companies I wouldn't expect are doing secure code training. There are more boutiques in the industry who compete with me who do secure coding training. So it's here to stay, but it has its limits. What the efforts I like a lot is when companies begin to standardize on reference architectures. They're using a standard cloud API architecture, and they have, instead of like 1,000 frameworks, they have a smaller number of frameworks. I think famously, one of the investment companies in the US who I've never worked before, like Vanguard, they're really into like a one solid architecture, and that makes them way more agile and able to train. I know Netflix, even though the attack surface of Netflix is a joke compared to most real software, sorry, Netflix, but Netflix, they bake a lot of security into their framework, where they brought in some of the best engineers on the planet with security knowledge, and they bake that into their framework. That helps reduce this. But your typical organization with either not enough staff or not enough maturity or too much staff and too many frameworks, they're always going to struggle to keep software up to date from a security point of view.
I suppose in layman's terms, I was sort of thinking as well, like, we've had clients for multiple years, and maybe there was 5,000 people in the business when they started being our client, and they had a cyber team of 8 people. And then 5 years later, there's 15,000 people in the company, and there's still a cyber team of 8 people. And, in some ways, I think there's a bit of pressure. And we talk about it a lot about, the lack of people. And, so you would assume if a company goes from 5 to 15,000, they may have diversified, they have more IT, they have more stuff, the more stuff to secure. But in doing that, we're not. I don't think anybody would agree that there's a linear growth in the cybersecurity capacity with the growth of a business. Yeah. I'm not sure if there should be a linear growth, but there should be some sort of growth, I think, to keep pace with change. But that's where I am with this stuff. Cool.
Now, here's the thing, though. Let's think about this. This is my experience when it comes to this kind of data. I would love to see a sort by all your customers who's got the best and who's got the worst here. And if you look at the best, I bet their numbers are way better than this. Those who take it seriously, they have significant lower medium time to fix and so on. Yep. And those top companies with a certain stat, those are companies I want to invest in. Those are companies I believe will continue to accelerate financially the next 5 years. Those are companies that have better competition in the market. Those are companies that when they're trying to close big enterprise deals, they don't just have a security story. They have actual security practice that eclipses their customers. So I've watched a few of my customers train with me for 7 years now, and going from a small company, in some cases, multi-billion-dollar companies. So that those companies that really take AppSec seriously, like their security officer is all about training, assessment, and constantly being involved with developers for security. They have third-party library update standards. They have intensive vulnerability analysis, and remediation is critical for the company. They grow faster. They close deals faster. They're able to handle the challenges. And 7 years ago, we didn't know if this was going to be a big problem. We had an idea, but now those who did roll the dice and invest in real secure software, 7 years later, they are so far of everyone else. Like the one customer I can't mention, when Log4j came out, they were good in a day. This is no big deal to them. Why? Because they had a rigorous DevOps infrastructure and a rigorous culture around when to update libraries. So I want to look globally at which companies have the ability to remediate fast as a technical capability, and I want to invest in those companies in a fund, and they will accelerate in the next couple of years.
Yeah, I think that's good. That's really good.
I agree,
words.
Marion says she wants to see. I'm sorry to interrupt you, Owen. We have a chat, and they're like, we'd like to see the breakdown by industry. And Marion, what I've seen is the more you're like a tech internet player, the smaller your rates are. The more you're like traditional retail, the bigger. That's quick 2 cents.
No, we could do that as well. We do have that data. We haven't really put it in, into the stats report. We could put it in before we publish it in a few weeks. Might be an idea. We give it to the Verizon DBIR every year in terms of the industry verticals, because it's something they do. But that's good. Thanks, Marion. We'll take that on board. Let's move on into the time, Theo, please. Next slide there. Yeah. Look, let's like flog a dead horse, but this is the age, right? This is the age breakdown of vulnerabilities we found in 21, right? And you'd expect to find 2020s and 21s there, I'm guessing, but if you see 57% of vulnerabilities were at least 2 years old. And then 70% of vulnerabilities were at least 5 years old. So that's nearly a fifth of all the vulnerabilities we found are 5 years old. And what worries me, most common vulnerability, this is all CVE stuff, but the most common CVE is crypto's logjam. Not very exciting. Most pen testers and security people have seen it a million times before, and I'm not even going to talk about logjam. The most common CWE in 21 is crypto. Wow, whoopee-dee, right? I think we can agree, Jim, there that it's just because everything has cryptography these days, and there's so much of it, people aren't fixing it, right? It's like because we've had so many iterations of flawed implementations of TLS and SSL in the last 10 years. People are it's just and to be honest, some browsers anyway won't even handle those levels, the broken levels of encryption anymore. So by default, your browser will protect you. If it's a browser based, but crypto's used in more places than just browsers. Go for it.
It's getting better. I mean, TLS configuration is getting better, but still, there's hundreds of thousands of sites around the net that have poor TLS configuration, and that's it's a common. I don't even think it's as severe of a problem these days. It is a problem. I think the other big challenges are we're pushing developers to use key storage mechanisms and hardware security modules for key management, and that's brutally hard to get right, especially at scale. So a lot of the things that we ask of developers, at least in this era, is so difficult, it's hard to get right and easy to break. And I think the saving grace is when we look at how all the major cloud providers are enhancing their solutions, if I'm coding to AWS, that's a really specific way to build APIs. And more and more, I have turnkey crypto capability that's really advanced. It's just emerging now, but today to set up TLS and set up crypto storage, it is brutally hard work. And my conjecture is in like 5 years, I can flip a switch and pay an extra 2 cents a minute, and I automatically get these crypto capabilities. Totally. So this is going to be way less of a problem in a couple of years in the cloud, is my conjecture.
Amen. Yeah, I believe that. What was concerning about with these, we had ransomware, cyber criminals, blah blah blah. Lots of major ransomware attacks in 21, and a few nice ones in 22. It's an industrial complex that we're fighting against. It's not guys or girls in bedrooms now and messing about. It's industrialized cybercrime, and what did find, and we'll cover it more in the report, the proper full report, is that a lot of the vulnerabilities, 2 years old, 4 years old, are still used by ransomware toolkits and sort of malware toolkits in order to, because once they get into your network, phishing attack, or or even an exposed RDP or something, so somebody gets into your network that way, like the Colonial Pipeline thing. Once they get into your network, it's just such a soft underbelly, because there's so much 5-year-old vulnerabilities and 3-year-old vulnerabilities, and these things are are known, and you can get the exploit code easily, right? It's on GitHub, right, or whatever, right? And that's what worries me about these statistics.
I agree.
It's just the age of some of the stuff, like 5 years of vulnerability, and we're finding 5-year-old vulnerabilities. Like okay, if you should be able to patch something or fix something within 5 years. Like just to be fair. But anyway, look, let's move on to the next slide, because I
Real
don't
quick,
want to keep our
How about SQL injection? Do you still find SQL injection? Because SQL injection showed up 1998, Christmas Day, Jeff Forrestal, Rainforest Puppy, Frack Magazine, 1998. That's like 23, 22 years ago. How come you're still finding SQL injection 22 years later?
No, I agree. Yeah, and it's a nice segue to the next slide here. Beautiful. That's beautifully done, Jim. I love it. So, most common critical risk vulnerabilities, in order. So critical risk, not all vulnerabilities, but the most common critical risk vulnerabilities on the app layer, the web layer, layer 7. SQL injection was top. So there you go. 24, 22 years old vulnerability, still finding it, still finding tons of it, And I think I'll agree that, these types of vulnerabilities are easy to find. And actually, if you're using a fairly contemporary persistence library, or like something that abstracts you from your database, something that makes database calls, or whatever, it's hard. Would you say it's hard to write SQL injectable code now, or not? Like, do most frameworks give you the ability to not do this?
It depends. If you're using like the criteria API, like programmatic queries, like for against Hadoop and NoSQL databases, they're automatically SQL injection resistant. But most of the teams I'm working with, they're still writing dynamic SQL and stored procedures. It's still the way to roll in terms of flexibility development. So I see a lot of groups move to other data storage mechanisms and then roll back to SQL. It's still a very standard way of talking to a database. And you can build a fully SQL injectable query and still functional. Everything works and passes QA. So this is why I think automated DevOps type scanning like Edgescan is doing for SQL injection is critical. I like it as a blocker. If I find SQL injection, you're not pushing code live, because it's really easy to discover SQL injection in automation. It's also easy to fix, parameterize your queries, and you'll stop one of the biggest risks in software today. So it drives me nuts that this is still around.
Amen. Because, even in the old days when we were in, OWASP Portugal, OWASP Greece in the early noughties, we were still talking about this stuff. And now it's still up there on the top of the list, right? It's funny, it's funny. And like something else we found interesting this year was malicious file upload. But like actually, just to cross-site scripting, right? Nearly any scanning tool, free or commercial, should find the majority of cross-site scripting vulnerabilities now, right? Right. Easy to find, hard to fix. What do you think?
So cross-site scripting was recently removed from the OWASP top 10 and rolled into the injection category, because at this point, even though it's complicated, we do know how to fix cross-site scripting. And it's not easy. It's a combination of, wait for it, contextual output encoding, HTML sanitization of HTML input, using the safe syncs in JavaScript that are not going to cause injection. In the client, in React or Angular, use something like DOM Purify to sanitize HTML input. Then you have the merging standards like the HTTP only cookie. You have you have content security policy version 1, 2, and 3. You have trusted types, the XSS protection header. Owen, that's like a dozen different programming level controls that we've introduced to developers to fix this stuff. SQL injection parameterize your queries, and move on with your life.
Okay. But
Right.
I'm gonna be devil's advocate there and say, like, all of those things you mentioned for XSS, right? Cross-site scripting. Do you think you're overloading developers with all this stuff? Like you know, they're sort of like, they want to write code, they want to be productive, they want to do stuff. They don't want to be trying to learn the 14 different ways you can prevent XSS. Like, I'm guessing some frameworks automatically can protect you against XSS, right? Well, others can't, right?
Angular is one of the best XSS resistant frameworks, but I don't wish Angular on my worst enemy. It's super expensive to maintain. It was written by a pack of PhDs, and it is super complicated to do simple things in it. It's now the Angular, once you do the Angular way, you can build some apps. It's got great security, but Angular is not the right tool for most apps. Most apps need either React or Svelte or Vue and their flexibility. And guess what? When you're using React, I can bypass you through unvalidated URLs that land in like an anchor tag. I can bypass React with like a lot of the styled components. They don't escape variables you put in the CSS blocks, and like, so even when you're using some of the best frameworks that supposedly defeat XSS, you still need specialized knowledge to use that framework in a secure fashion. So other than Angular, I don't see any really highly resistant automatic frameworks. And again, Go templates is close, but again, I can't use Angular for every programming need. So developers still 20 plus years later need special knowledge to build secure user interfaces. That's why you see 26% of vulnerabilities in the cross-site scripting world. It's ultra non-trivial to fix, and even to this day.
Yep. And it's a fun vulnerability from a pen testing side point, because once you find it, you can figure out cool ways to use it, right? It's not just, it's a payload delivery mechanism, I'd say.
Absolutely. And Owen, as one, like, I'm a computer scientist and a professor, but I'm also a farmer. I just bought a 30-acre farm in like middle of nowhere in Northern California. And that's the farm that cross-site scripting built. I tell you, like, I teach like 4 hours of cross-site scripting in the course, and I've been teaching this now for almost past 15 years, and it keeps showing up. I keep getting asked to talk about it. It's the farm that cross-site scripting built.
Yeah, I was going to say that the same thing. It's similar ways. Cross-site scripting has put shoes on my kids' feet for 10 years. So God bless it. Long may it continue.
Long may cross-site scripting continue. Cheers.
All right, let's move on. High risk. So there's cross-site scripting in this as well, because when we find cross-site scripting, this is reflect as well, where the last category could have been stored or reflected, and it's contextual. So sometimes you find the same vulnerability, but it's in a different place. It could be unauthenticated cross-site scripting versus authenticated. It could be, and so on and so forth. So that's why it's in two places. So we're not trying to fill up the gap here. It is not an error. This is statistics, people. But when we look at high risk, it's cross-site scripting, right? But the second, well, we've talked about that. So let's briefly talk about authentication, session management, all that, and authorization. So if you look at 2, and actually if you look at 3 as well, file path traversal. Again, for me, that's an authorization issue, as well as lots of other things, because you can just directly access stuff, right? And there's no authorization check on your request, on your the way.
Especially direct object reference. In my world, that's one of the worst vulnerabilities there is, because it's easy. I'm stealing like your entire customer database through just traversing a number. And I go to developer fix this, and there's no standard framework to fix indirect object reference. They got to go figure it out. So that's that's even though it's 5%, that's 5% of like really nasty, hard to fix critical stuff.
Well, you only need one. You only need one, as the man says, right? Yeah. Okay, let's go to one of the last slides.
Yes, sir. Yes, sir.
So API. So this is different. It's all software. It's all bloody software, but this is API. So this is API critical and high. And you mentioned direct object IDOR, or direct object reference, and that's something we find a lot in I think it's called BOLA. It's referred to as BOLA as well, or broken object level. So we're finding that very hard. But then again, it's funny with API, right? API is like a silo in itself, right? There's API security scanners, pure play vendors, But in effect, if you look at the taxonomy of vulnerabilities, it is similar. Like injection attacks is on top, right? There's lots of types of injection attacks APIs are open to, right?
And we can find them easily. We know how to. It's an easy automated thing to find, even though it's important. And finding indirect object reference and BOLA with automation is not as trivial. Not as trivial.
I agree. And then there's some unique things like rate limiting, right? So the idea that you can abuse somebody's API, you find this a lot in the insurance industry, where even legitimate insurance companies are trying to use their competitors' APIs to get quotes.
Without permission,
in order to underquote, when you're doing online quotes, right? It's not unheard of. It's a dirty secret, but it's not unheard of. So the idea, and there was other things, like we have a new postcode system. It's not new now. It's a company called Aircode. It's a postcode system where every property has its unique identifier, and if you have the unique identifier, you type it into Google and it pinpoints exactly where that property is, right? Because some parts of Ireland haven't got even road names, right? They don't even have, there's no numbers and houses or anything. It's sort of rural. So postcodes are good, but the Aircode stuff is, for example, was being used by lots of other companies, or abused by lots of other companies, and they were delivering their own services on the back of the Aircode system. So that again was an example of API abuse, and the idea of rate limiting and sort of trying to leverage things for free, something else that I thought was interesting, it was the mass assignment piece, which is the idea. So
Rails, is that mostly Ruby and Rails type stuff, I imagine?
100%. And the idea that, again, with mass assignment, is some data you can't see. The developer is saying, well, if you can't see it, you can't change it. And the idea will be is that you actually are able to you are able to change it, and alter attributes that were never intended to be changed, stuff like that. So that's something that is, and again, authorization.
Much I can do with mass assignment to cause harm. That's a big one.
So the numbers are chunkier there. There's not as much difference. I think one of the reasons for that is because we did bundle injection into one category in API, where they're broken out in web. But that's the way we did it this year. I'm open to correction for next year if anybody wants to just send some comment. Look, is there anything else we want to cover before we call it a day? Because it's Friday. I really appreciate your time.
I really enjoyed that a lot. Hey, Alexa,
it was good.
Play Irish traditional music. Excuse me.
Playing Irish traditional music on Amazon Music.
Let's end it properly.
Here we go. Oh, here we go.
Come on, you're Irish. Show me what you got, buddy. Come on.
Right, I'm out of here. I got to go to the pub now. Jim, thanks very much.
That was super fun, Owen. Anytime. I'll talk data and AppSec with you anytime. Thanks for having me on your show. I appreciate it.
Yeah, no worries, man. We'll do it again. Take care. Thanks, everybody, for attending.
Thank you, everyone.
Bye.
Thank you for attending.